Hello guys, today we are doing this machine, of which I'm not gonna go deep into theory, but I will just focus on calculation, on how to approach each and every question when it comes to this machine. Here on the board I wrote the EMF equation. Sometimes each and every question can ask you to calculate an EMF equation or an induced EMF. The equation, it says that E is equal to 2 alpha n zp over 60, the whole over 60c, where our E is an induced EMF and 2 is a constant, and flux, and this phi is a flux of which it is measured in Web. Then n is a rotational speed, where it is measured in R per minute, and Z again, Z is a number of conductor. They usually give you Z, and P again, P is the number of pole pairs. Then again 60 is a constant, C is a number of parallel paths. And you need to note that when you're given this equation and they say on that certain question your C is 4. Actually, you need to note for C we only have two basics or condition when it comes to C. The first one, it says for a lap winding C is equal to 2p, where C is a number of parallel paths and 2 is a constant, P is a number of pole pairs. Remember, this P, we don't have unit for this C and this P. And again, the second condition, it says for a wave winding. For a wave winding, C is equal to 2. And you must also note that when you are given a number of pole, a number of pole is different from a number of pole pairs. When you are given a number of pole, and let's take that they have given us number of pole 5, 8 number of pole, 8 number of pole. When you're given such, and you need to substitute your P here, in order for you to get a correct answer, you need to know that this number of pole must be divided into 2 so that you can get the number of pole pairs. Pole pairs, not number of pole. But when it comes to C, when I give a number of pole, and here they say 2 times P, where P is number of pole pairs, not number of pole. You can substitute your 8, avoid this, just say C is equal to 8. But if you want a number of pole and you are given, if you are given a number of pole and you want your C, it's on to you whether you wanna divide this number of pole into 2 so that you can get 4. Then when you divide this number of pole into 2, this become number of pole pairs. But when you substitute it like this, it's the number of pole. And when you substitute it like this, you don't include this. You just say C is equal to 2, C is equal to 8. But when you start to divide it, it becomes number of pole pairs. Therefore, you can come and substitute 4 here, of which is gonna be 8 again. Then we come to calculation. In a calculation, we have 3 different types of circuits. But for now, we are going to concentrate on shunt generator and shunt motor. On shunt generator, we have this circuit. This circuit where our RF is a field resistance, and we have armature, and inside an armature we have armature resistance and induced EMF through the armature. Then this we call brushes, and inside the armature again we have interpole resistance. but for now we are not given interpoles. Usually they don't give you interpoles to such a shunt generator. And here, this VT is a terminal voltage. Then this P is a given P, of which you consider it as P out. Then IF is a field current, and IL is a load current, and IA is an armature current. You must note that for a generator, current comes from an armature, then it distributes itself into two, of which you consider this thing as parallel. And remember, in parallel, VT is equals to VF, of which our VT is the terminal voltage, and our VF is a field voltage. VF and VT are equals to, of which our source is this armature current start here and distribute, meaning the first equation to approach this kind of circuit shunt generator is to say our A, which is armature current, is equal to field current plus load current. And again, our field voltage, I said, is equal to terminal voltage, and is equal to field current times field resistance. If you are not given VF, of which is field voltage, we consider this as equals to this. And let's take you are given everything. You are not given IF. To calculate IF is to use VT is equals to IF times RF. Then you make IF the subject of the formula. You get it. They usually give you terminal voltage because it's the voltage that is on the load. Then again, to get our VT, remember on a shunt generator, the induced EMF on an armature is greater than the terminal voltage on the load. Reason being, the current starts here. This is our source, so we can say that V terminal is equal to EA, where EA is an induced EMF across the armature, minus IARA, where IA is armature current and RA is armature resistance, of which it is here this armature current and this armature resistance multiply each other, then you get a V terminal. If you need V induced EMF, you make EA the subject of the formula, of which is going to be EA is equal to VT. Take this to the other side, it becomes positive, of which this is going to plus VT, then you get EA. And remember, sometimes they won't give you such equation or VT or EA. They will just give you the component of EA, of which is a flux, is an M, is a Z, is a P, is a C. Then the only thing that you need to do is to substitute accordingly and calculate IA, or they can say calculate the flux of this circuit. The flux of this circuit is, you use this equation, you make this flux the subject of the formula, then you get your flux. When it comes to power, we said the power that is generated here on a shunt generator, the power that is generated here, this is a load. We consider it as power output, an output power, and it's equal to VT times IL, where VT is a terminal voltage and IL is a load current. And P in is a power input. Power input is generated here on the armature. Power input is equals to electromagnetic power plus rotational power. And you must know that the rotational power, usually you are given a rotational power, and a rotational power is equals to a mechanical power, of which our electromagnetic power, you can get it using IA using EA, where your EA, you do calculate it here using this formula. And IA is here. You calculate your electromagnetic power, you calculate your power input, then you can use your power input and power output to calculate an efficiency of that certain circuit that you are given. Then we go to shunt motor. Shunt motor, there is no difference between shunt motor and shunt generator. The only difference is that a shunt motor operates different from a shunt generator, meaning the circuit is the same but the operation are different. You can also see, compare this shunt generator and this shunt motor. We do have RF, P, V, VT, VT, P out. But here, actually, for a shunt motor, we almost have the very same thing, but it differs when it comes to operation, because now our source is this load, of which our terminal voltage now is greater than EA, of which EA is our induced EMF, and the power that is generated here now, because this now is our source of this circuit, this power now we consider it as a power input. This is field resistance, field current, load current, armature current, armature resistance, induced EMF through the armature. How to calculate such component using this circuit? The first thing that you need to know is that usually you are given IL. If you are not given IL, you are given V terminal and power input. You can calculate your IL using V terminal and power input, of which here is the formula. You can calculate it. IL is equal to power input over V terminal. Then the second one, you can say IL is equal to IF plus IA, where your IL is a load current, IF is a field current, and IA is a armature current. And you must know that this field current row and this armature current row are parallel to each other, of which this current, load current, it distributes itself into two, where now your V terminal, again your V terminal is equals to VF. V terminal is equals to VF is equals to IF times RF, where your IF and RF is field current and field resistance, of which why do we say V terminal is equals to field V terminal is equals to field voltage? It is because here we only have resistance, and here we have resistance and voltage, of which our V terminal now, in order for us to get V terminal, our V terminal is equals to IA plus IA times RA. This RA is in series with this voltage, of which this voltage is an induced EMF, and to get V terminal is to multiply IA times RA, then you plus it then you add it by EA. Then when it comes to power output, now this armature current on a shunt motor, this armature on a shunt motor produces power output. It produces power output, and the load produces power input. And our power output now is going to be PEM minus Prod, where our PEM is a electromagnetic power and Prod is equal to rotational power. And you must note that rotational power is equal to mechanical power, and we are always given, actually you usually being given a rotational power or mechanical power. If you are not given, they will say calculate it using perhaps using an armature resistance and or they can say that the rotational power is 10% of the of an armature current. Therefore, you need to calculate it, multiply it by that 0.1. Then you get your power rotational. But here is the formula of calculating power output, and this power output is for this armature. Then when it comes to power, the electromagnetic power, if you're not given electromagnetic power, here is the formula to calculate electromagnetic power. It's equal to EA times IA, where your EA you can find it using this equation. Using this equation, VT is equal to IA plus IARA. Then you take this to the other side. Because it's positive, when you take this to the other side, it becomes negative. Therefore, VT minus this is gonna give you EA, where your EA, you come and substitute it here, and IA you come and make IA the subject of the formula here, so that you can get your electromagnetic power. Sometimes they can say calculate the component of a rotational speed, or the rotational speed of the circuit. The only way to calculate a rotational speed is to use this formula. EA is equal to 2 alpha. This is 2 phi NZP over 60C, where you see is in parallel path, and this phi is a flux in web, and this is a rotational speed, and this is a number of conductor, number of pole pairs, where is P. And again, your efficiency, you can calculate your efficiency using this formula, power out over power input, where your power out is this. You can calculate it using this formula always. And your power input, we are usually being given. If you are not given, you can calculate it here, then you substitute and get your efficiency. I'm gonna do the example of this shunt generator and shunt motor. Okay guys, now we are doing an example of a shunt generator and shunt motor, as I was explaining the basic of it. Our examples say that a shunt machine has armature and a field resistance of 0.04 ohm and 100 ohm respectively. When drive at 600 R per minute, the machine delivers 50 kilowatts at 460 volts. Then they say, number one, we must calculate the efficiency, the efficiency of the machine when running as a motor. The second one, it says the efficiency, we must calculate the efficiency of the machine when running as a motor. The first one when running as a generator. The second one when running as a motor, taking 50 kilowatts from the same supplier of 460 volts, and we must assume that the machine has a rotational losses of 400 watts. The first thing that we need to do is to take out the data that we are given. In the data we are given an armature resistance, an armature, and a field resistance. Where is our armature? They say the machine has armature and field resistance of 0.04 and 100 ohm respectively. It means these numbers are given according to the armature and field resistance. The armature here is 0.04 ohm. The field resistance is 100 ohm. It's 100 ohm. Then we are given a power. Since the first question says you must calculate the efficiency when the machine is running as a generator, our power here, we are going to consider it as power output. 50 kilowatts. and they say it delivers 50 kilowatts at 460. This 460 volts, we are going to consider it as terminal voltage. Always the given voltage, unless it is stated otherwise, the given voltage is a terminal voltage with terminal 460 volts. Then, how do we determine our efficiency? The first thing that we need to do is to draw the circuit of this machine when running as a generator. Here it is. I did draw here the circuit. Just that I didn't label it. I did label, but I didn't specify the values of each. Here we have 100 ohm. The armature resistance is 0.04 ohm, and the field is 460 volts. It's 460 volts, and the power output is 50 kilowatts. How are we going to determine the efficiency of this shunt generator, shunt machine? The first thing is to calculate. Actually, remember our is power out, our power input. This is our efficiency. We do have power out, we need power input. How do we get power input? We need to calculate. Here we are given RF, and I say that if you are given this, you can calculate, if you are given V terminal and power output, you can calculate your I load. And if you are given RF, and we must note that, remember, our V terminal is also equals to the voltage that flow in this branch, and we can calculate IF, then we calculate IA. How do we calculate IL? I will say IL is equals to power output over V terminal. Our power output is 50 kilo over 460 is equals to 50 kilo divided by 460. We get 108.696 ampere. Then the second step is to calculate the I field. How to calculate the field current? We say it V terminal equals to V field, equals to IF, RF. So we need IF, and we do have V terminal, we do have RF. So we're gonna go straight to the equation that says IF is equal to V terminal over RF, of which is 460 divided by 100 is equal to 4.6. 460 divided by 100, 4.6 ampere. Then now, since we have IL and IF, and remember, for a shunt generator, this armature, we consider it as our source, meaning the current start flowing here. Our IA is gonna divide into two, where we get IF and IA, and IL. Therefore, we say IA is equal to IL plus IF is 108.696 plus 4.6 is equals to 108.696 plus 4.6. We get this answer 113.296 ampere. After getting this answer, now we need EA. How to get EA? Remember, for a shunt generator, EA is greater than VT. So we are gonna say EA plus IA RA is equal to V terminal. I say EA plus IA times RA is equal to V terminal. Why? Since this is our source, this RA it is in series, but it is in series with this parallel branch of which is RF and R load. So we're gonna make EA the subject of the formula. EA is equal to VT minus IA RA. Therefore our V terminal is 460 No. I made a mistake here. It's negative. Negative here we're going to add, since this V terminal is greater than, this VEA is greater than V terminal, we're going to add C plus. Remember our IA we got as 113.296. Substitute it 113.296, put bracket. And our RA we said is 0.04. Then when you calculate, we say 460 plus 113.296, 0.04. We get 464.532 volts. This is our EA, this is our EA. So from here, since we have EA, from now on we need to calculate P in. Remember P in, we say is P EM plus P rod or P mechanical. And then for now we don't have this, we do have P rod, we don't have this. How do we calculate this? Well, we say P EM is equal to PEM is equal to EA times IA, and we do have EA is 464.532 is 113.296. Then we get 464.532 113.296. We get 52629.617 watts. Then from there on we can calculate our P in. P input is equal to PEM plus P rotational. Our PEM is 52629.617 plus 400. Remember, this is our P rotational plus 400. It gives us 53.0296 kilowatts. Then from there on we are being asked to calculate the efficiency. How do we calculate the efficiency? We say efficiency is equal to power out over power input. Then our power out, since it's a generator, we say our power out is 50 kilo. Then this one is our power input, 0.0296 kilo. This K and K cancel each other. Then we're gonna get 50K divided by 53. We get 94.29%. The answer that you got here, you multiply it by 100, then you get 94.29%. Then we go to number 2. Number 2 say that the efficiency, we must calculate the efficiency of the machine when running as a motor, taking 50 kilowatts. Now they are saying taking 50 kilowatts. This 50 kilowatts is going to be our power input from the same supply source of 460 volts. We must assume again that the rotational losses of the machine is running. It has a rotational losses of 400 watts. So our first step is to draw the circuit again. I'm not going to draw the circuit, I'm going to change this one, shunt motor. Then remember, in shunt motor, this sign changes, the operation changes actually. Since we are in shunt motor, this becomes our power supply. So our current starts from our power supply, comes again. This is IA is going downside. This IF is going this side. IA, it divided into 2. Then this is our V terminal. Now because this is our supply, this is our source, this becomes power input, of which it's gonna be like this. How do we calculate power output? How to calculate the efficiency? Since we have power input, we need to calculate the power output. How do we calculate the power output? Since we know that we have VT, the same is true. We are going to calculate IA, IL, or IL is equals to. Now, since this is our power input over V terminal equals to 50 kilowatts divided by 460 equals to 113.696 ampere. No, 108.696. Then IL, we calculate IF. We say that IF is equal to V terminal over RF is 460 divided by 100. Again, it's 4.6. But now 4.6 ampere. But now to calculate an ammeter, we said, since IL is divided into 2, we're gonna say IL plus to IF plus IA. We make IA the subject of the formula, of which is gonna be IA is equal to IL minus IF, then 108.696 minus 4.6. This is going to give us 104.096 ampere. This is our IA. We go straight again. We calculate EA. How to calculate EA? calculate EA. After calculating EA, we calculate electromagnetic power. Our EA is gonna, since we know that in a motor V terminal is greater than E terminal, we're gonna say EA is equal to V terminal minus IA RA, and V terminal again, V terminal is 460 minus IA. Our IA we say it is 104.096. Our RA is 0.04 ohm. Then 460 minus 104.096, 0.04, we get 455.8336 volts. Then from there on, we calculate PEM is equal to EA IA. Then EA is 455.836. IA is 104.096. Then we get 455.836. 104.096. We get 47.571 kilowatts. This is our PEM. Then we come again and calculate P output. Our P output is equal to PEM minus P rotational. Since on a shunt generator, our P input we add PM plus P rod, but for now it's shunt motor. This has become our P in become our output. P output PEM minus, we minus the rotational losses now, because actually 47.571 kilo minus 400 is equal to minus 400 is equal to 47.051 kilowatts. Then after this, we do have power output and we do have power input. Our efficiency, that's the power out over power input times 100. Gonna give us, our power output is this, 47.051 divided by 50 kilo times 100 plus 2 divided by 50 kilowatts. We get 94.1%. Thanks for watching our video.